Next property here is the distributive property, which says if a number is right next to a set of parentheses and they're adding or subtracting inside the parentheses, you can multiply the number by all the terms in the parentheses. So on this first example, normally what we would do, order of operations would say, let's do the parentheses first. So it would say, let's take 3 plus 5, which is 8. And then we would do 2 times 8, which is 16. So what I'm going to show you, you might think is pretty crazy why we would even do the problem this way. But I'll show you in a minute why, a couple reasons why we might be interested in this. Distributive property says instead of doing that, since they're either adding or subtracting inside the parentheses, we can multiply to these numbers. So we can multiply 2 times the 3 and then plus 2 times the 5. So 2 times 3 is 6, 2 times 5 is 10, and then 6 plus 10 is 16. So if you'll notice, we got the same answer. Now, every year when I'm teaching this, people look at that though and they say, well, yeah, you got the same answer. Look how much more work you had to do though. So, 2 other examples we're going to look at to illustrate why distributive property could be helpful to you. If you look at the second example, if we would do the parentheses first, if we would add 100 plus 8, we would have 108. I could come up with a more extreme example, but I won't. And then we would be doing 2 times 108, which I'd probably be working out by hand. Okay, rather than doing that, distributive property says we could multiply 2 times 100 plus 2 times 8. 2 times 100, oh, that's easy, 200. 2 times 8, 16, 216. So maybe making it a little bit easier than the 108 times 2 that I would be working off to the side. Okay? If you're still not convinced, this final example is a definite reason why we need distributive property. If you're given a variable and they don't tell you what the variable is equal to, and they ask you to simplify, distributive property is our only way we can simplify this. Okay? We have no idea what x is equal to. We have to use distributive property to simplify this. So in this case we would do 4 times x plus 4 times 2. So 4 times x would be 4x, and then 4 times 2 is 8. Notice we're doing these because multiplication always comes before addition with the order of operations. So we would get this simplified to 4x plus 8. That's considered to be more simplified. So 4x plus 8 would be my simplified answer for that expression. And again, I don't have any option. I don't know what x is, so I can't add the x and the 2 together. Example 2, they're asking which of these expressions are equivalent. So one thing we can do, if you look at that last expression, we can use our new skill of distributing. We can do distributive property. So if you look at this one, we could take 4 times 2x minus 4 times 1. So if we do that, 4 times 2x, just like 4 times 2 is 8, 4 times 2x would be 8x. And then we'd have minus 4 times 1, which is 4. So we would get 8x minus 4. We don't know what x is, so we can't do anything else with that. And you might notice that matches exactly with that first expression. some people might be tempted to then say, well, 8 minus 4 is 4, so it's going to be the same as the middle one also. And that's not actually the case, though. Remember, we have no idea what x is equal to. X could be equal to 1. X could be equal to 1 million. We really don't know. So, with not knowing what that's equal to, those are not going to be equivalent to each other. Okay, remember, if they're equivalent, means I could put any number in for x, or whatever my variable is, and I would get the same thing. Okay, so just to prove to you, I'm going to pick a random number, 10. So let's say this one I put a 10 in. So 8 times 10 is 80, minus 4 is 76. If I put a 10 in this one, 4 times 10 is 40. So 76 and 40, not the same. Guaranteed those are not equivalent. Okay? It's possible we may be able to pick one random number that these would be equivalent to each other. Okay? In this case, the random number would be 1. If I would put a 1 in place of the x on this first one, 8 times 1 would be 8, and then 8 minus 4 is 4. On this one, if I did 4 times 1, would be also 4. Okay? Just because it can work does not make them equivalent. It has to work for every single number that I put in for them to be equivalent. So only the first and the last of those are equivalent to each other, like the book says. Okay, so let's look at the try it. So on this example, again, we can key in on that last expression. So the last expression, we can use distributive property here. So we're going to take 5 times 2y and then plus 5 times 1. When I use distributive property, notice the arcs I'm making up above here. That's a reminder to myself that I need to multiply to all of these parts. A common mistake people make is they multiply to the first term and not to the second term. So when we do this then, multiplication happens before the addition, so 5 times 2y would be 10y. 5 times 1 would be 5. We've got 10y plus 5, which is identical to our first expression, which means those are identical to each other. Once again, I could randomly pick a number. Once again, it happens to be 1. That would work where that would match up where we would get the same answer as 15y, but those are not equivalent expressions. For example, if I put 100 in place of the y, 15 times 100 would be 1500 or 1500. 10 times 100 would be 1000 plus 5 is 1005. Not the same, so those are not equivalent. One thing the book doesn't really talk about yet, we'll get to later, but I feel like is valuable for you guys to know at this point, is like terms. Like terms, the variable part is identical or there is no variable. In other words, we have constants, just plain numbers with no letters. So for example, 3x and 2x, those are like terms. Notice the letter, the x, is identical. 5 and negative 4, those are like terms. They're both constants, just plain numbers, no variable. And the reason why I care about like terms is I have to have, in order to combine something, they have to be like terms. I can't combine unlike terms. I can only combine like terms. So for example, if I have 3x plus 2x, just like 3 plus 2 is 5, 3x plus 2x would be 5x. In other words, 3 times a number plus 2 times a number is the same as 5 times that number. Obviously, we know 5 minus 4. Those are like terms. I can take 5 minus 4, which would be 1. So, kind of a key thing there. They have to be like terms to combine. So, You know, kind of going back to some of the things we just looked at, you know, if we had 10y plus 5, I can't just combine those together and say that's 15y. One has a constant, or one is a constant, one has a variable. Those are not like terms. Can't be combined.